Hello there. Welcome to our first video tutorial of Swift Toolkit.dev. Today we have Andrew Barba, who wrote SwiftCloud, and in the past who already joined us for Dev Conversations. Today we're gonna see how we can deploy a real-world application to AWS using the different pieces of SwiftCloud. How are you doing, Andrew?
I'm doing great. Thanks for having me back on.
Thanks for joining once again. Before we jump right into the code, I want to talk a little bit about what this project is that we're going to deploy. So I wanted to build a newsletter system or some system that is able to send emails whenever there are new articles on the website. And after investigating a little bit and studying, I thought it could be a good approach to use Lambda because of it being serverless and not committing to any costs. So I built an application that is composed by an HTTP API. As I said, it's supposed to be working on Lambda. It's a Hummingbird app. So basically, it's gonna do two things. This API. One, it's gonna store the email addresses of whoever is interested in getting the emails, and the second thing, it's gonna receive requests, HTTP requests, whenever there are new posts available. The content management system is gonna update this API. And the second part of this newsletter system is actually who's gonna send the email. It's also gonna be a Lambda. This Lambda function is gonna read the SQS events that the HTTP API is gonna store. And finally, it will compose the emails and send each request to SES, the simple email service. So basically, we're gonna use four resources of AWS. The first one is Lambda. The second is DynamoDB to store and read email addresses. The third one is SQS, the simple queue service. And finally, SES. So, Andrew, can you remind us a little bit what is SwiftCloud and in what ways it can be helpful for this use case?
Yeah, absolutely. So, I mean, you look at these services that you have here, and if you were to take any of them individually and go log into AWS and try and configure these things, it's incredibly overwhelming to try and do so. And it's really hard to iterate on, right? So if you were to manage this all in the AWS console, trying to connect your functions, your servers, to your queues, and getting your permissions correct, all those types of things are just maybe you could do it once, but you definitely can't do it twice. And trying to continue, iterating on that architecture is just really not feasible for any type of application. But the infrastructure here is really incredible, right? You get to have a $0 system that can handle thousands and thousands of requests per second, process hundreds of thousands or millions of messages with effectively no work on your part other than, configuring these services. So we have this incredibly
Right.
modern infrastructure, but it's really hard to configure if you're just logging into the console and trying to click buttons and do so. So the point of Swift Cloud was to basically say, let's configure this infrastructure with Swift, very similar to what a lot of people are doing in other languages. Like if you were to configure a Golang application, you might use Terraform to configure these things. But in general,
Mhm.
this concept of infrastructure as code, it's very rare that you get to define your infrastructure in the same language that you're actually writing your applications in. And that was really what we wanted to do with Swift Cloud. You're writing your applications in Swift. Let's go configure our infrastructure in Swift. And by doing that, we can do a lot of really great things like amazing defaults, security best practices, and all those things that are really hard to reason about in the console are just kind of taken care of for you inside of the Swift Cloud SDK. And then we do our best to give you escape hatches. If you want to customize those defaults, there should be plenty of ways to do so.
So that's the famous that's a definition of the infrastructure as code, right? And that's what we're gonna do. It's gonna help us setting all this up.
Exactly.
Um, so I'm gonna open this project with the existing targets here on Xcode, and I'm just gonna quickly show it around. I have one folder, one directory for the HTTP API target, and another one for the mail sender target. Each one of these is gonna be a different Lambda, and I have some shared code between them. Another advantage of having all this is that I can share some models between these two targets. And in the package.swift, I also have the shared target, and I have two executable targets. I have this one, the mail sender, and I have the HTTP API. Currently, they only rely on the Lambda runtime and on Hummingbird packages, and also on Soto, so I can interact with AWS. But in regards to the deploying, there's nothing here. So what's the first thing I should do?
Yeah, I mean, first of all, the setup here looks great, right? There's a lot of things that are done really well here. We got to separate things into separate packages, right? So now you're not overloading one package with any too much responsibilities. So yeah, the setup here looks amazing. And is similar to the setup, what we wanted to do with SwiftCloud is we wanted to define your infrastructure just in another Swift target. That way it's a
Right.
real Swift app. You get all the features of Swift.
So I can start by declaring a new target, right?
Exactly.
It's also
Yeah. So
it's also
yeah,
executable.
yeah. So this will be a new executable target. We can call it something like infra.
Infra. Yeah. And I'm gonna leave this empty for now.
Perfect.
Let's add the dependency on SwiftCloud.
Let's do it.
Yep. So package URL is github.com/swift-cloud, right?
Yeah, SwiftCloud is the org, and then SwiftCloud is also the name of
the project,
the package.
And let's use the main branch.
Perfect.
And then here I need to depend on there's the AWS Cloud package, correct?
Exactly. Yeah. So today SwiftCloud primarily supports AWS, but it's designed in a way where we can just add more packages for other clouds. So to start, we're just going to add the AWS Cloud package. And hopefully in the future, we'll be able to support things like DigitalOcean, Render, Fly, and all the other cloud providers.
And all the other ones. Yeah. Okay.
Yeah. Oh, and the package will be Swift-Cloud, all lowercase.
All right. I always make these mistakes. And let's see if it finished. It's still failing. Okay. Interesting. Another error now. Not resolution error, but it's now saying that there are no files here in sources/infra because we don't have this target for it yet.
Yep.
So let's go ahead and create one. Let's call it infra, capital I, and I'm gonna do infra.swift. This is where we're gonna create the definition of our stack, right? So what should I import first? AWS Cloud.
Exactly. So we'll go ahead and import AWS Cloud. And the way SwiftCloud is designed is you basically define a project, and projects have a lot of features to them. So the first thing we'll do is we'll define a new struct, and we can just call it.
Let's call it infra now.
Yep, perfect.
And it needs to conform to.
Yeah, and this is going to conform to an AWS project.
Yeah, and we have Xcode suggesting weird stuff.
Exactly.
We need the main attribute here, the main keyword on the struct, because this is where our entry point, and we also do not conform to the project protocol. Let's add the single function here, and it's a single function called build. Can you tell us a little bit about what I should do here and what is the outputs?
So basically inside of this function, this is where we're going to define our infrastructure. And then the things that we want printed to the console. So to start, we can just return an empty object, and we'll go ahead and fill this in later. But this is where we're going to set up things like queues and our functions and our Dynamo database, and anything else, any other infrastructure that we defined as part of our project. There's other aspects to the AWS project.
All the resources we showed here, right?
Exactly. Yeah, so
Yeah.
all these things are going to be defined in the build function.
Okay.
And the beauty of this being a real Swift app is you can organize your code however you want. Like as this infrastructure gets larger, you can create more folders and things and basically set
Yeah,
up, you know,
because they're all Swift files, so it's not like
exactly.
not like YAML where you need to have everything in one. It's you can compose it, use your own functions, and be very customize it as you said. Like I could add here another file just for a single function and have it there.
Exactly right. Yep.
Okay, so let's start by the HTTP API target, the function for it.
Yeah, I think that makes the most sense.
Okay, so let's call it HTTP API, and it's an AWS dot. I can do AWS dot to see all the different things that SwiftCloud already gives me. So I'm gonna use this one. The function currently it has only two parameters. It has a name and a target name. The name is how I'm gonna call this in my project. So I'm just gonna use this name, and target name. Now this needs to be the name declared here, right? That's what SwiftCloud asks SPM to build for.
Exactly. So yeah, we are going to the other benefit of this is you're not dealing with Docker files or any other weird setups. You don't have to know the correct way to build your project for AWS. We take care of that. So the only thing we really need to know
Mm-hmm.
is which target is associated with this function. And there's a whole bunch of other parameters that function support, like complex things like adding it to VPCs, different concurrency features, things like that. But this is basically the most simple function you can create.
Mm-hmm.
And the only other thing we probably want to enable here is you want to invoke this over HTTP. So there's another option
Correct.
called URL.
URL I see here, and then I can do enable or disabled. We want to. I remember a while ago, if I wanted to call VHTTP, I would need to configure API gateway. Nowadays, this is embedded into Lambda already, right? I can have
Exactly.
I can have it like for free I mean, without the need to have to configure something externally. Yeah, and all right, there are a few more parameters here. Let's say I think that we should increase memory for having.
Yep.
I'm gonna use this 1024 megabytes. There's also timeout, right? What do you suggest here?
Yeah, so timeout it could be a really important value depending on your setup. I think for HTTP APIs, somewhere in the 10 to 20-second range is reasonable. And then for
Mm-hmm.
something like a job processor, you might want longer, right? If you have
Yeah,
long running jobs, you might want something, 10, 15 minutes.
yeah. Let's go with 10 seconds then. I think it's safe. There's also another thing here, environment. We're gonna see this later on. So once I have this HTTP API, I could start returning this as the output, right? That's one of the things I'm interested in. So this is the outputs type is I can initialize it um, with a dictionary, but it also conforms to expressible by dictionary literal. So I can just do a string. So for example, I can do HTTP API, and then we do this. That's enough.
Yeah, and we'll just return the URL property because that's the thing that we'll
Yeah,
want to,
that's what
paste
we
into.
want, right?
Yeah, exactly.
Okay. What's the difference between these two?
Yeah, so function URL is the underlying resource. Behind the scenes, creating a function might create a bunch of resources that we also expose. But in this
Okay,
case, the
but
URL is just the string value.
this is the
Yeah.
main one, right? Yeah. Right. Okay. All right. Now let's configure the two services that this function needs. They are the DynamoDB
Yeah, and if you want, you could actually
table.
we could run a deploy just this, just to see how the initial deploy would work, and
Okay.
then we can just add more
Okay.
infrastructure on top of it.
Let me see. Yeah, we have a hello world function. We can test that. So if we open terminal, okay, what should we do? We should run the infra target, right?
So now we're actually going to run our executable target infra. And
Uh-huh.
there's a few different commands we can use here, but to start, let's just go ahead and deploy.
Yeah. And is there any parameter I need to pass?
Yeah, and so the main parameter you have to pass in basically every command is a stage. So we can do dash dash stage, and
Okay.
we can pick any name we want here. So the
Let's go
beauty
with
of this,
development.
yeah, this is perfect. And the
Uh-huh.
beauty of this is you can deploy to any stage you want, any name you want. You can manage production stages, development stages. You can use feature branches. It's really, really flexible. And this basically lets you separate your infrastructure and your different environments. Great. So yeah, the first thing you can see that it's doing is actually building your target. And behind the scenes, it's managing the Docker files and whatnot for you. So as long as you have Docker installed, you don't have to worry about configuring anything else. SwiftCloud is just going to build for the Amazon Linux target for you and make sure that it's built correctly to run on Lambda.
All right, so it seems that it's SwiftCloud is done, and we see here the output that it's exactly the string that we wrote as the key in the output dictionary, right? And it gives us this URL. Before trying to call it, let's just go over to the Amazon, to the console, and let's look for this function in the Lambda console. So if you write here development, we already have one. Development newsletter HTTP API. We can see that it's configured as the package type is an image. This with the Docker image that we built. And for each stage, there's gonna be a different name here, right?
Exactly.
Okay, cool. So this is exactly the name we set as the stage. So let's try to call this. Let's do cur, and we get the response here, hello world. That's a good sign. Usually lambdas, they're really fast. Sometimes in the first launch, not so much. Depends on a few different parameters. Let's go ahead with the other components.
Yeah, let's do it.
Okay. All right. So the first thing I want now is the DynamoDB. So I want to declare here subscriptions DynamoDB. And again, I'm going to do AWS, and I'll choose DynamoDB.
Perfect. Let's do it.
And newsletter subscription is what I want. Okay. And primary index, can you tell us a little bit what this is?
So Dynamo is a highly specialized key value database, and so the primary index is basically your unique keys for your index. So this can be designed in a bunch of different ways. For your use case, I'm assuming you probably have a pretty simple primary index
Yeah,
that we can define here, but yeah, learning DynamoDB indexes, secondary indexes,
it's a whole thing by
it's
itself.
an entire field. Yeah.
Yeah, okay. So as you said, my use case is very simple, and the subscriptions that I save into the database, they are gonna be simple. It's a simple struct with email, maybe name, but the main thing here is the ID, which is a UUID.
Excellent.
But it's saved as a string, right? So we are gonna do only a partition key, and this is a tuple, right? That's what it expects from me here.
Yep. Yep.
Let's see here. Yeah, index key is a tuple of name and type, so the name is gonna be ID. That's the codable key.
Exactly.
And the type is gonna be, we have here a few different ones. It's a string. Yeah, it could be a number, it could be or binary data. We're gonna just go with string. And how do I connect them?
So this is what makes SwiftCloud, I think, really, really interesting is, typically you might generate some connection string and then you have to set that as an environment variable. And now you potentially, or you're even worse, maybe you're committing your secret connection URL into your code. And so our goal is to avoid all of that. And so what we can do is we can just link the DynamoDB table to the HTTP API, and all of the permissions are handled behind the scenes using AWS best practices, so proper roles and policies and things like that. So you can just
Yeah.
type HTTP API.link.
Yeah, and then here I can pass. I see that there's this arrow here, and I can even pass one linkable or an array or just variadic parameters. For now that we only have this one, and that's it. And now my Lambda should have access to the DynamoDB with no effort required.
And the fancy thing that happens here is by doing this is we will also expose environment variables for you inside of your Lambda function. And so that way every stage gets a unique, it actually gets a unique Dynamo table,
Yeah.
and all the data is isolated per stage.
Yeah, and I think I saw this in the README, and that's what you mean here, right? So if I link a DynamoDB table, I'm gonna use DynamoDB underscore the name of the resource and underscore name. We're gonna see you're gonna see this in a bit. And the other component we wanted was being able to write events to a queue, right? To a SQS queue. So it's already suggesting me here, SQS queue. Let's see what's the real API here. And there's name. I think it's enough only the name in this use case, right?
Yeah, perfect.
Okay, so we want to link this as well.
And so by linking this will let the HTTP Lambda send messages to that queue. So nothing is processing those messages yet, but this is what allows you to send messages to the queue.
Very nice. What else do we need here? For this one, that's enough. I want to now create another function for the other target, which is the mail sender. I will define mail sender as also a function. Oops. We're gonna do something similar here. So this one is newsletter mail sender, and the target name is mail sender. That's the same as the one in the package. And what else do we need here? Do we need to expose this as HTTP API? Not really, right?
Nope. Yeah. So yeah, that's the benefit. Since this is just a job processor, we don't want it exposed to the internet. And so, yeah, we can just disable the URL.
Not only we don't want to expose, but also it's declared here as a Lambda handler, and what actually the input is an SQS event. So an HTTP call wouldn't even be transformed into a differently than the HTTP API.
Exactly.
Where the handle function we have, well, it's already implemented by Hummingbird, by the Hummingbird Lambda package, but you can see that the event is an API gateway request instead of an SQS event. So that's good. We're not exposing this. Let's also go for the same two parameters here. Okay, and we need this mail sender needs to use the SQS resource as well. So I'm gonna define mail sender link SQS queue.
This is actually a little bit different. So in this case, we want mail sender to subscribe to the queue, right? It shouldn't need to send any messages to the queue. So we could actually call, instead of linking it, we'll call SQSQ.subscribe. Okay. Yeah, we'll actually flip this. So we'll take we'll call SQSQ.subscribe, and then we'll pass in mail sender.
Okay, so I'm subscribing the mail sender to the queue.
Exactly.
Right? And the last resource that we want to use, it's going to be SES. It's the simple email service. And it's important to note that in order for you to use SES in production, you need to have there are two things you need to do. First, you need to validate a domain or an email as a sender, which I've already have done. And the second thing is getting approval from AWS to be able to send.
So this will be a good example of we really can't fully configure SES in code because there's approval process by AWS. You have to set up some DNS settings and things like that. So in this case, what we're going to do is we're basically going to import something that's already been configured, and we'll reference that configured email domain.
How should I do this? Maybe email equals to aws.ses. I already see it here, and then I have this get domain identity. I assume it's this one.
Exactly. So this is just going to reference that previously configured domain.
Okay. Yeah, so the domain in this case is swifttoolkit.dev. And I'm actually gonna link it to the mail sender function.
So now by linking the email to mail sender function has full permission to send email. But notice that the HTTP API does not, and it doesn't need to because it's not responsible for sending emails.
So as you said, email is only used here, although the queue is used by both. And it's also interesting to note that the HTTP API links to the queue because it's going to write to it, but it's not going to listen to events from it. So we use this subscribe, as you said. All right, so let's call now. I see Xcode is already suggesting me to have a mail sender URL. Actually, we don't want the URL here.
Yeah, it won't exist because we disabled it.
Yeah, but I want to see a queue. Maybe there's an address that I want to... There's the SQ that I'm not going to use it, but I just want to see that it's correctly printing. Okay, and there's also the DynamoDB. We don't need to print it, but we could. I'll just leave it empty. There's also one last bit for another resource that whenever I send an email, I want to store this into the database, like as a record that this was sent. Actually, this is done also in the HTTP part. Whenever I send a message, I want to store this. So let me find where so I have this function register send record. So whenever I send emails, I wanna store an identifier for this email and how many people to how many email addresses. So I do a put item operation, and I have this send records table name. So I am gonna use two tables here. So there's the table for subscriptions and table for the sent records. We're gonna soon replace this with environment variables, but let me just create the second DynamoDB. And I want the name newsletter sent records. And it's also gonna be, the ID is also a string, even though now the ID it's not gonna be a UUID, but it's still gonna be a string. It's the identifier of the email, and here I do send records, and I need to use it. And so I'm gonna pass this here as well.
Perfect.
So there's no need to use the email resource here, but we will use the email here. Let's now read all these names, these table names, because we don't have them right now, and we don't want to have it here. I want to access this from the environment, right? So let's
and this is important because as you deploy to different stages, the name won't be static, right? You'll have a dev table versus a prod table or whatever it might be. So yeah, we can go ahead and we can read from the environment. I think there's a few ways to do that. Lambda might provide a helper, but you can also use process info.
Yeah, I think that there's this environment which is from Hummingbird. So I'm going to go with this. Let's see how we can do this. So I'm going to do env.get as get. It's going to return a string. And I'm going to go with, now I need your help. So in the README, we see that it's DynamoDB underscore and then the name. So in this case, this name here is the subscription, so I'm gonna go with newsletter subscriptions.
Yeah, we basically take your name and we turn it into this upper snake case.
Yeah, so it's exactly the name that I passed here. Newsletter subscriptions, the dash becomes an underscore and everything capital. And this is optional. I won't handle right now if it goes wrong, but this could be a throwing. We could throw an error here. And I'm gonna do the same for the sent record. So it's also in DynamoDB newsletter sent records name. And the queue URL, which we print as an output. Where is it? The queue. Yeah, so the queue is here. We need to use its URL. We can also head to the README here and see queue. So there's queue name URL. So we can copy this. Go to our here where we access it and do again env. Oops. We can do env.get. And the name is, in this case, the name is the name that we set here for the queue.
So yeah, just newsletter mail.
SQ, yeah, newsletter right mail, everything capital. So I go here. So this is gonna be capital newsletter mail. And also I'm gonna do this, but they should all have a value. So I'm not gonna worry about handling errors now. And this should be it, right?
Yeah, this looks great.
So let's try to build it. I'm gonna use the same stage.
Great. So now you're gonna see it's gonna build two targets, right? One for HTTP and the other for your mail sender.
In the first time was only the HTTP API. So now it's both.
Yeah, and it's also worth pointing out these first deploys when you add a bunch of infrastructure take a lot longer. Subsequent deploys are much faster because it's only diffing the changes.
Yeah, maybe only updating the Lambda itself, like not without the need to recreate the tables, the policies. Okay.
Look at that.
Yeah. Both Lambdas deployed, and we can go again to the console. And now if we go to DynamoDB and look for development-newsletter, if we go here and do development, there are two tables here, exactly what we wanted. One is development newsletter subs for subscriptions. SwiftCloud capped this, the length, and we have the sent one. So if we go here, we can see that there's the subscriptions table, and it's empty. If we go to explore items, it's empty. Let's now try to create a new subscription. Now we want to test that storing the emails is working and also sending the emails is also working. Let's call the API here. It's the Lambda function URL, which is this one. And I'm gonna call subscriptions/new. And in the data, I'm gonna pass a JSON object saying email, and I'm gonna put my email address here. And application JSON as the content type. I'm setting the header so my Lambda can decode correctly this JSON. And I'm gonna pipe this into JQ, which is a cool command line tool to visualize the JSON. Yeah, so we see here that status is pending and that it was created, this record for my subscription. If we go to the console, we can see that we have this development newsletter subscriptions table, and we also have the other table for sent emails. If we query here the records, we see this one, which is exactly the values that we saw here. And if I open my email client, there we go. We just got an email, and here, if I click confirm, it's also gonna, you can see here that it's also gonna confirm the subscription. and it's gonna send the new articles posts for people who subscribed. And before we wrap up, I wanted to touch a little bit on environment variables and also see some of the results of the magic from SwiftCloud in the console. Let's head over to the Lambda and we can look for the development newsletter HTTP API. And if we go, it's configuration, right? Environment variables. We can also see the function URL, which is exactly the one that we typed here in terminal.
Yep.
And environment variables, we see exactly the keys that we used, the values that SwiftCloud used to connect between all the different services, right?
Yeah, this looks great.
Yeah. So there's another thing that I wanted to show, also related to environment variables, which is I configured here a middleware for making sure that I'm the one calling for some APIs, because, for example, there's in the subscription controller here, I have a function that lists all the users, all the email addresses, and I don't want this to be publicly exposed. So I configured a middleware, and some of the methods that I want for my own usage, I want them to be behind this middleware. And this authentication middleware is set up here with a string. We can jump to the implementation and see that I have a function that's verify auth header. It's a throwing function, and if the header is not present, or if the header is not exactly the header is not exactly what I configured in the initialization of the middleware, then it's going to throw an error for any of those requests. So any of those requests that don't contain the master auth header, they're going to fail with an unauthorized error, which is 403. Yeah, no, 401. Sorry. So currently I have this as my super secret header, but I also want this to be an environment variable. So I want to use a environment variable that I'm gonna create the name. So let's call it maybe master auth header. Also here, I also need to do again, it would be better to have all of these to throw an error if they're not sent. Here, for the sake of simplicity, we're gonna go with double quotes, an empty string. And now I want to inject here, whenever I build my infra target, I want to take that from the environment. So how we're gonna do this now?
Yeah, so this would be on your HTTP API, right? So now we can actually pass in a custom environment variable here.
Yes, so here we can do environment, and for now it's an empty dictionary. You know what? I wanna create here another file for errors, and I'm gonna do import foundation, and I'm gonna do, let's call it an enum error, and it conforms to Swift error. And there's going to be a case missing auth header. And here, let's try to do this. SwiftCloud doesn't provide any special way of accessing the environment variables. I'll just go with process info. Let's go with guardlet my auth header equals to process info dot process info. Yeah, and it already did a lot for me here. And instead of throwing a fatal error, let's go with throw error dot missing auth header. What's complaining about? Yeah, it cannot find process info. I also added here foundation. And so we have the auth header, and let's see how so it's master auth header. I'm just calling them with different names so you can understand that this is a value that I expect when running the deploy command, and this one is a value that I expect to be present when Lambda runs in AWS. So we're gonna do here master auth header equals to the auth header that we got here. So if we run now this just as we did before, we should see an error here. Yes, we got it here. Probably if we go with a better, if we implement custom string convertible, we should see a better description for our error. So I'm gonna take this auth header, which is the key for the environment variable. I'm gonna do my password. And I'm gonna do the same command again, which is deploy to development. So now when running this, we shouldn't have this, we shouldn't get this error while building. And when we deploy our function, it should contain this, the middleware should contain our auth header.
Oh, there we go.
Okay. All right, cool. So we finished with this. So now if I try to call one of those, let's say I want to get all the subscriptions, I should get a 401 here. Okay, good, unauthorized. Yeah, and if I do curl-i, curl-i, I can see exactly the error and the message. So now, in order not to get this, not to get the error, I need to pass in the header. So I'm gonna do -h. So the header should be, already forgot. Let's see here, auth middleware, verify auth header. So it should be master-auth. And the value should be my password. Now, if we run this, there we go.
Nice.
I'm gonna pipe this into the JQ again. So see, this is exactly the list that we have here in our database. All right, so to wrap up, all we did here, we basically deployed to AWS 2 Lambda functions using SQS for queuing. We used SES for sending emails. We used 2 DynamoDB tables. We linked between them, and we did this without writing a single line of a Docker file, without writing a single AWS policy roles. All this taken care. How awesome is this, Andrew?
I mean, I think it's pretty awesome. That's why we made it. I hope,
Yeah.
and this is really just like tip of the iceberg type stuff. I mean, there's so many other types of infrastructure you could design using this model.
Right. It's also important to maybe to mention that I could have gone for a simpler design here, but for learning purposes and also for teaching purposes, I think it's a pretty good use case of how, as you said in the beginning, how things can be separated, responsibilities can be isolated, and we take advantage of the way SwiftCloud allows me to link between them.
You certainly could set up, a single web server that just tries to do all this itself, and that might work, early on in your project, but then it gets really hard to manage the complexity later on. So yeah, this type of infrastructure really lets these projects scale to very large sizes, massive number of requests per second and users and all those things.
Right. Amazing. Yeah, I want to still do another video about how I implemented all this with Hummingbird Lambda and everything else. And maybe also another video to test all these things playing together locally instead of on AWS itself. I think that's it for today.
Exciting. Well, thank you so much for having me on. I'm really glad we got a chance to put this together and show everyone.
Yeah, thank you. Thank you so much for all your help, all the code you put up. Thanks for your time. It took us a while to make this happen, and I really appreciate it.
No, my pleasure. Yeah, I really appreciate you getting the word out there. If other people are interested in this type of work, please open pull requests. I would love to continue to support a lot more resources on Amazon and other cloud providers in general. So yeah, feel
Yeah.
free to get involved.
If anyone is interested, also we have an article that we covered the basics of SwiftCloud, so you can check it out. I'm gonna leave a link as well. All right, thank you so much, and see you in the next one.
See you
Bye bye.
later.